Hello everyone, welcome to our webinar. Thank you very much for joining. Today's webinar topic is Moldex3D eDesignSYNC for Creo. And today with me there is Tommy Liu. Tommy is from the product manager team, and he is going to present to you the demo of Sync for Creo and how it works. So after the presentation, after the demo, you will have the Q&A session, and that will be the time for you to ask any questions that you have. And now I will pass the microphone to Tommy.
Hello everyone, my name is Tommy. I'm the product manager of eDesignSYNC for Creo in Moldex3D. Okay, it's my honor to demo Moldex3D eDesignSYNC in this webinar. Okay, in the next 30 minutes, I will keep you guys silence until the Q&A section. If you have any questions during my presentation, feel free to type it in the text box, and I will answer those questions in Q&A section as well. Okay, here we go. In my presentation, there are three parts. Part A, there I will give a simple introduction for tell you what is injection molding, and then tell you what is eDesignSYNC. And part B, I will demo the basic functions and the design tools in eDesignSYNC. And then I will interpret the benefits of eDesignSYNC in design optimization. Okay, in part A, I want to talk about what is injection molding. This is an injection machine, and injection molding is one of the most common methods of converting plastic from the raw material to a real plastic product. And you know, injection molding is a black box. Nobody really knows what happened inside. So we analyze injection molding by four phases: filling, packing, cooling, and warpage. Okay, and we all know that cavity filling is a key step, because cavity filling is a process of moving metal film in 3 dimensions and a transition phenomenon. Okay, and non-Newton's flow and coupled heat transfer are usually issues in the filling process. So in general, during the filling stage, any product defect will occur if there are design flaws, improper process, or improper material. Okay, so, and then packing is to analyze the packing or holding process in the injection molding. And then cooling system is very important in injection molding. An ideal cooling system can cool and solidify the plastic parts, avoiding unwanted information occurred during mold ejection and so on, right? And then warpage is the summarization of all effects in whole procedure of injection molding, and it can predict the product expansion. Okay, so what is eDesignSYNC? I will tell you, nowadays many different CAD files are used by designers, so it may cause data loss when users export CAD file to another CAD environment, like this. Okay, so we provide the eDesignSYNC for Creo. It is an easy-to-use interface embedded in PTC Creo, bring a seamless workflow from design to simulation. Yes, I had heard that some other software may make simplification on the product, which integrates with CAD software, but we never do that. with the complete support of eDesignSYNC, Moldex3D design, and the designer are able to synchronize design change and check the performance in design and manufacturing with their familiar CAD environment. Okay, so eDesignSYNC has supported PTC Creo elements Pro E5 and higher, and PTC Creo Parametric 1-3 version. Okay, and then I want to show you several common defects occurring in injection molding right away, including welding line, short shot, air trap, and warpage. Okay, the first is weld line. Weld line is the line formed by two different melt fronts joined together during the filling stage. And it will decrease the structure strength of the final product and increase the product surface defects. Sorry. Okay. So if you encounter this problem, we suggest you increase the melt temperature or change the gate location. Okay. And next, short shot. Short shot is incomplete filling of the mold cavity. When short shot occurs, okay, we suggest you to increase the injection pressure or change the gate location. Yeah, they may solve your problem. Okay, and then air trap is formed by a converging melt front trapping a small bubble of air. It may occur at multiple locations inside the cavity, and we can conclude that an air trap will occur at the location where melt front comes in all directions. Okay, regarding this problem, we have to improve vent location. Okay, and then warpage is this problem in injection molding is a result of unequal volumetric shrinkage of material. Okay, as it cools from a melt to a solid state. So this variation of temperature and pressure will induce the variation of a specific volume and the density of polymer. So this variation induces the warpage of injection molded plastics part. There are a lot of factors affecting plastics part warpage, such as material selection, part design, mold design, and process conditions. Okay, so user can use eDesignSYNC to detect these defects from simulation results and then fix it by modifying geometry, process, condition, or both. But we want to know what kind of process do we fix these issues. Yes, the designers would design their parts performing an injection molding simulation with eDesignSYNC for checking the design of products are suitable or not, and examine the analysis results. If there are some defects in this model, we can modify the geometry and our process condition to improve the quality of a product. Next, analyze the revised model and check the analysis result again and again. Okay, repeat the process until the product has fully developed. Yeah. So, and then I will demo the basic function and the design tools in PTC Creo. Okay, I had open model. Something I want to tell you, we have to open the CAD file in assembly format in PTC Creo and use Moldex3D tabs to launch the eDesignSYNC. Okay. The tree menu on the left side includes all the elements of injection molding. Okay, the model is a simple connector with a solid runner and cooling channels. Okay, so in eDesignSYNC, we have to assign the material to each element by this easy-to-use dialog. And well, if users want to know the detail of a material, they could open the material wizard and to see the material bank to find every material you want. And Moldex3D provide more than 7,000 samples of material in this bank. So for this case, I choose one of the ABS material to for this project. Okay. Okay. The color will be changed if your setup works. Okay. And then we have to check these models are suitable or not. And Moldex3D eDesignSYNC provides some indicator tools assist users in performing quick evaluation with their products. Okay, so we can use get location advisor to add tools to add gets automatically, and it will give users some suitable location to put your get on. Okay, but in this case, I already have a runner and a mail entrance, so I just demo these functions. Okay, and then cooling time indicator. It helps us to find the hot spot. Yes, and we can reduce the thickness or improve the cooling efficiency for specific location. Yeah, it have a hot spot. Okay. Before mail front enter the cavity, it would inject from mail entrance and pass through the runner. So I also have to set the runner and mail entrance. Okay. And after get or the mail entrance set, we can use the LT indicator to check whether the get location are suitable or not. Okay. And then SYNC indicator also can help us to check whether the get location are suitable or not, and the red area has more probability to cause SYNC. Okay. And then we to assign the cooling channel. Okay. We also can modify the diameter of these cooling channels. Okay. And we provide automatic Moldex building. And we can use these functions to auto generate the Moldex, and the material of Moldex is necessary. Yes. And I choose a default one. We go OK. The Moldex will execute overall cooling channel automatically to let the inlets and outlets be configured in the Moldex boundary. Okay. And the cooling channels, inlet and outlet, could be automatically generated after the mold base has been built. Okay. And we also offer a probability to extend this simulation with overmolding and intermolding, yes. And we also can set the sensor on the cavity, and it will respond the pressure or temperature results versus time to users. And there is another optional function for advanced hard runner system. Okay. If we want to run analysis, and before the analysis starts, we should set the simulation sequence and the process condition, mesh level, project setting, and the report format for your analysis. And the eDesignSYNC provides very useful sequence, including filling, cooling, and warpage to users. And the process conditions we have to set before the analysis is filling time, packing time, and melt temperature, mold temperature. Yes, and we provide the remote computing process to enhance computation performance to run analysis in less time with more complex model with large amount of elements. And users can submit the analysis job through the server by this dialog to manage and speed up the computing processing in high performance computer. Yes, which reduce the burden of your local machine. Okay. And then about the mesh level. There are 5 levels of meshing which you can choose from. Okay, level 1 is the most recommended level for the user who want to have a quick filling analysis result. In most cases, the solid mesh generated in this level is plated from for demo purpose. And under this level, the program generates the solid mesh with fewer elements and performs CAE analysis with higher acceleration ratio. Okay, and the level 5 is the most accurate level for getting in deep analysis for all kinds of parts. Under this level, the program generates mesh more elaborate and performs CAE analysis accurately. However, it is to be noted that more hardware resources are required. Okay, and we have to set the saving path, and also can put a remark on the wrong data. Okay, eventually we provide a report generator for users, choosing one report format, and the report will be generated automatically after your analysis has been finished. Okay, so when I run the analysis, I would get the result, and I will check the results of this connector. Okay, I have finished this analysis. So when we check the result of this model, in filling analysis results, Okay, I want to show the animation of feeding state. And I will slow down the display state. Okay. The main front time result shows obvious race track effect in the feeding animation, and the race track effects lead to unbalanced flow and may cause uneven volume shrinkage, air trap, and wheel line in this part. Okay, so when we find this problem in this model, we have to fix it. This red track effect can be solved in several different ways, but for this connector, sorry. Okay, never mind. The red track effect can be solved in several different ways for this connector, but we can decrease the thickness on one side of the part to balance the flow. So we have to modify the model, and this model, we can see we cut a slot on one side of the wall, and we want to analyze the modified model to confirm that the design change is effective. Okay, so for comparison, the analysis setup is the same as the original one. So, okay, let's examine the result of our revised model. Okay, so please wait a minute. Okay. That's the play. Oh, okay. We find out the flow pattern of the main front is more balanced than the original one. The main front even reached the end of a cavity almost at the same time. So we know our design change is effective. So expect flow balance. User may concern the location of flow termination. Yes, and I just in the end of my demonstration, so I give a simple summary. The integration between a design and a simulation creates a high-performance design, yeah, and a platform that gives designers the ability to examine, optimize, and seamlessly create more designs. Finally, it really enhances product quality and reduce costs through eDesignSYNC for Creo. Yes, so I hope this demo make you know more about the eDesignSYNC. Thank you again for your attention. If you have any questions, please type in the chat box.
Thank you, Tommy, very much. Now we're moving on to the Q&A session. Please type your question in the chat box. We will give you a few minutes for doing that. Okay, we have one question. It's about if this module works only with Creo 5.0.
Okay, I think eDesignSYNC we has supported with Creo 1, 2, 3, maybe or Pro 5. I don't know. You means Creo 5 is Pro or Creo Prime Trick. If it's Creo Prime Tricks, we had supported 1 and 2 and 3 version.
Okay, thank you. We're waiting for your other question. We have another question, and the question is about fiber orientation and if it's possible to run the analysis of fiber orientation.
Yes. In eDesignSYNC, we had supported the fiber orientation calculation, and we have some results can improve some. I don't know. We have so many models. We should use the fiber material to calculate to simulation. So I think the fiber orientation is already our function. Yes, in our eDesignSYNC.
Okay, thank you. Okay, we have another question. Both software should be installed in the same PC. What would you recommend for a good output of results? We don't really understand the question. I think since you have a Creo version on your computer, you will obviously have Moldex3D on probably the same one. So yeah, I think they should be installed on the same computer. Okay, seems like we don't have any more questions. It was a pleasure for us to have you here today. Seems like we still have one question. Sorry. Yes, it's a question about the new module embedded in Creo, and the question is it's provided by Moldex.
And I think the injection simulation, the new function in PTC Creo is called CMA, and it's also provided by Moldex3D, but CMA only can calculate to the filling and packing state, and it can't extend the calculation and the simulation to cooling and the warpage stage. So if you want to get the fully support the injection molding simulation, eDesignSYNC is a better choice.
Right, thank you. We have another question. Is it possible to define the initial fiber orientation at the injection point as boundary condition?
Okay, these questions, in injection molding simulation, and the first stage is filling, so it's a flow condition. So when the material it can't contain fiber, and the fiber orientation is always changed, so it's not a solid state. So in present model, we can't to define the initial fiber orientation in the beginning, but we also to consider this possibility in the future.
Thank you. Please write your questions. We will wait a few more seconds. If we don't receive any more questions, I would just like to say thank you very much again. And it was a pleasure for both of us to have you here. After this webinar, I will send you a confirmation email with a link to the video, so you can have the materials from today's webinar. Okay, so I guess this will be the last question for today. Is it possible to export the automatic generated mesh?
Okay, I think it is possible to export the mesh in your model, and we have a project file in the model you had to finish the analysis. So there are some STL file. It means you already have the mesh file, so you can export that.
Okay, thank you again, and have a nice afternoon. Bye-bye.
Thank you, guys. Bye-bye.